You see, today we shall discuss exercise 11B number 6 BTEC. We have already discussed A, B, C, D, E, how to find out equations of straight line using different forms of equation of straight line. We have already discussed 5 types of equation we have already discussed. The first one is point slope form. In point slope form, a point is given on the straight line and the slope of the straight line is also given. We have to find out the equation. Then the 2-point form, in which 2 points are given on a straight line and we have to find out the equation. Then slope intercept form, in which the slope of the straight line is given and the y-intercept is given and the equation is calculated. Then only intercept form, in which the x-intercept and the y-intercepts are given and the equation is calculated as x by a plus y by b is equal to 1. And then the normal form. In normal form, a normal is drawn from origin to the straight line and the length of the normal is given p, and the angle the normal makes with x-axis is given, that is alpha. P and alpha are given. We can find out the equation of straight line, and the equation of straight line is x cos alpha plus y sin alpha is equal to p. Using these 5 different types of equations of straight line, we are solving problems, that is exercise 11B number 6. And you see the 6th bit, the question is find the equation of straight line bisecting the line segment joining 3 minus 4 and 1 2 at right angles. 2 points are given. A and B are 2 points whose coordinates are 3 minus 4 and 1 2. Now we have to find out the equation of the straight line which is bisecting the line segment AB at right angles. Suppose this point is C. Bisecting at right angles. So we have to find out the equation of the straight line, that is, you see here, this is the straight line L whose equation is required. So you see, first of all, we need the slope of the straight line and a point on the straight line. As you know, C is the midpoint of AB. So using midpoint formula, we can find out the coordinates of point C. So coordinates of point C, that is midpoint of AB, which is given by 3 plus 1 by 2 and minus 4 plus 2 by 2, which is equal to 2 and minus 1. 2 minus 1. So the coordinate of the point C is known and C is on the line, that is L. Now we need the slope of the line. You see, the lines L and AB, they are mutually perpendicular to each other. Slope of AB we can calculate using 2-point form, that is y2 minus y1 by x2 minus x1. So 2 plus 4 divided by 1 minus 3, or it is equal to 6 by minus 2, which is minus 3. The slope of the line AB is found to be minus 3. So slope of the line L, so it is equal to 1 by 3, because when two lines are mutually perpendicular to each other, the product of their slopes is equal to minus 1. M1 into M2 is equal to minus 1 when they are mutually perpendicular to each other. So if one is minus 3, the other is 1 by 3. Using this formula, the slope of the straight line is 1 by 3. And a point on this straight line is 2 minus 1, and the slope of this straight line is 1 by 3. Now, using the first type of equation we have already discussed, that is point slope form of equation of straight line, we can easily find out the equation and consider a point here. Point C is 2 minus 1, and consider a general point, that is xy on the line, and taking these 2 points again, the equation is, the slope is y plus 1 by x minus 2. This slope should be equal to 1 by 3, which we have already calculated. So this implies 3y plus 3 is equal to x minus 2, or x minus 3y minus 5 is equal to 0 is the required equation of the straight line, that is L. So you see here, try to understand. The question was to find out the equation of the straight line which is bisecting AB. Bisecting AB at right angles. This angle is 90 degree and C is midpoint of AB. So using this concept, we have calculated the point coordinate of the point C, which is the midpoint of AB, and the slope of the line L, which is perpendicular to AB, and it is 1 by 3. Now using point slope form, the equation is found to be x minus 3y minus 5 is equal to 0.